All right, in this video, we're going to be talking about inheritance. So inheritance is basically, how we can, in object-oriented programming, we can create subclasses or child classes from other either, parent classes or, base classes that are used. So the idea is that, object-oriented programming is a way to break up your code. Also, to make code reusable. So it's our goal in object-oriented programming, well, there's lots of goals, but one of the goals is every object we create, we want to make them very concise. It makes it so our somewhat primitive brains can wrap our head around what has to happen in every single class we write. Even though in the examples we go through in this class, the classes are definitions are pretty simple. You can still have some pretty extensive class definitions, but saying that, object-oriented programming is one of the tasks is to break problems up, so it's more manageable. I've worked with base codes that have had millions upon millions of lines of codes involved with them, and without a organized way and with a bunch of rules, it makes debugging harder, makes trying to figure out what the big problems are and things of that nature. So in this example, we're going to create a console application. We're going to create two classes. I'm going to make a generic car class, and then we'll make some attributes that every car has, and then we'll make a specific child class that will inherit from that class. So we'll go over here, new project, Java. Call this Notes5. Keep our main here will be our test class. And create our instances. But let's go ahead and create a couple new Java classes. First one we'll call this automobile. So we'll give we'll create a private attribute. We'll give two attributes here, both strings. String make and color. All cars have a make, all like the manufacturer, and all cars are a certain color. Create a quick constructor. This can be something where we can just set initial values. Make the default color red, and this dot make equals Chevrolet. And then we write our get and set functions. Again, I'm using the this keyword to signify the actual attributes up here. If you don't put this, you can omit the this if you really want to, but it just makes it so if for some reason you forget and create your function variable the same name as your attribute, then you won't be screwed, because this refers to the actual attribute, whereas a local name without the this in front of it would just be meaningful to the function itself, not the overall object. So we got our sets. Let's make our gets those strings. Get color and get make. And finally, we'll create a print function. So we have make. Color. There. So this is going to be our base class. I'll test it out along with when I make our second class, but we're going to make a second class now. So the way you want to do that, go ahead and do another Java class. So I'm going to create a more specific automobile class here, and for whatever sakes, I'll use our Traverse. We have a family car Traverse. It's a Chevrolet too, and very good car. I'll call this class name Traverse. So some of the things like a Traverse, it's kind of hard to think of great examples here, but something that a Traverse might have might be that differentiate between traverses are things like I guess maybe the drivetrain, which is like four-wheel drive, front-wheel drive, things like that. And another thing could be the number of seats. I think our car has 1, 2, 3, 4, 5, 6, 7, but if we had the middle row as a full seat, I think we could probably sit like 8. So, so for this, again, we can create some get and set functions. Hopefully, during these parts, you're fast forwarding all this. Forward and then set on seats. There's a lot of busy work in here. And again, object-oriented programming might seem like a lot of busy work, especially when we're doing small functions like this, or small applications like this. But again, the whole idea here is to make a large code base, very extremely manageable. Here, so we have our very basic functions here. So really the trick with all this is that we've created 2 separate classes here. But if I want a Traverse to be actual child class of the automobile class, I basically just have to put a keyword in there, and the keyword is going to be extends. So many object-oriented programming languages have different keywords. I think maybe inherits is one. But Java uses the word extends to signify that a class is inheriting from a different parent, from a certain parent class. One thing that does remain consistent: a class can only inherit from one parent. It can't be 2 different objects that it inherits from. I know it's kind of different from obviously from the real world, but it's just a rule set. Now, when we talk about interfaces later, classes can implement multiple interfaces, but they can only inherit one parent or base class. Whatever, they both mean the same thing. So what that means is, if I come over here to our notes class, when I create a Traverse, I'll say my wife's name's Kristen, so Kristen's Traverse equals new Traverse. So I create a new instance of our Traverse class called Kristen's Traverse. If I type that instance name, hit the dot, you can see here that in addition to the get and set functions of the Traverse class itself, the get and set drivetrain, get and set num seats, we also have the ability to do set color, set make. It's because our Traverse actually has the same attributes as the automobile class here now because of this wonderful extends keyword. So now it has a make and color. The only downside with this is that not a downside, but because actually, can I go to a new split? not what I want to do. I want to split horizontally. Okay, so you can see both of these at the same time. Not how I want this to split. Clear this. Clear this. Can I drag this over here? There we go. That's what I wanted to do. So here you can see the automobile class here. Here's our traverse class. So both right now, currently, I have these set as private access modifiers in the automobile class. That just means the only thing that can modify these things are functions within this class. Now, if I actually make this one of these protected, that changes things a bit. So it's not, protected is not necessarily public, but it means certain things can modify it. And this is also, the way Java handles protected is slightly different than other programming languages like C Sharp, but for the intention is basically the same. So if I set color to protected, it means two things in Java. It means one, any class that inherits from this class can directly modify that. So here I can do color equals blue, or this dot color equals blue. And hey, it lets me do that. If I made that private, it would say, no, you can't do that. I have a red line. So protected lets me do that. Now, the other kind of weird thing, which always kind of trips me up because I'm, I code in multiple languages. At work, I'm at C Sharp all the time, is this protected also means package. So I know we talked about packages before. Anything that's in the same package knows each other exists, which is fine. I mean, C Sharp has, and other languages have similar things in their, namespaces. But the protected keyword also kind of makes it so any package within that any class within that package, if it's protected, it also has direct access to modify. Oops, what did I do? To modify that value. So you can see color even within main here, which doesn't main this Notes5 class doesn't inherit extends from automobile. You can see that it can even access this. But if we went to, let me disable this. So here's the Notes5 package. If I went over here and created a new package, Notes5 whatever package. So now we have a Notes5 whatever package. If I create a new class in there, test. And because we're not in the same package as Notes5, I'd have to go here and say imports Notes5.star. Or let's see. Why is it like that? What am I missing? Oh, not import. So if I want to import that package like this, and here, let's create a function. If I create a traverse object in here, traverse t equals new traverse. Notice that t dot, so now we're not in the same package. We're in this Notes5 whatever package. I create an instance of our traverse class. I'm trying to set t.color, and you can see it's not letting me do that. I still have access to these public functions, but because we're in a different package, protected means I couldn't access the color. Whereas in this guy, even though, because we're in the same package, it lets you do that. So that's a Java only thing. In C#, the protected keyword means only classes that are derived from it, or child classes, can have access to the protected stuff. But Java decided to make it for package only, so it's kind of odd to me. So let me just delete that. That's just well, I guess I can keep that there. It's not hurting anyone. Save it. Okay, let's going back here. Okay, let's talk about private protected. I guess we can just write an example out here. Traverse dot set color. Dot set drivetrain. It's full drive. Dot set num seats, I guess 7. And then finally so we can call the print automobile function, which is defined in the automobile class. So because the traverse class is an automobile, it has access to this, especially since it's public. But we didn't make a print function over here in the traverse class, so if we want to get those things, we got to actually print those out. So get drivetrain and get seats, and then we'll change it here. Drivetrain and number seats here. And this is a function, so I need my parentheses. So let's go ahead and run this. Our output, if I hit F8, and there's our printouts. Wonderful. So you can notice here in these videos, I'm really trying to get a lot of examples here where I'm putting breakpoints and I'm stepping through. That's, if you learn anything from this class, being comfortable with breakpoints and stepping through programs, and you're well on your way to becoming a fairly decent programmer. Okay, so that solves some things. So we've talked about creating subclasses. When you create a subclass or a child class, use extend keywords. It does become this object. Now, whether or not it can directly access some of these things is based on the private or the access modifiers of its functions and attributes. Now, there are some gotchas for some of these. When you inherit from a class, you got to be careful that you follow some rules. So, for example, say I wanted to create a print. I didn't look to see what functions were available in my parent class, and I wanted to do create a function that basically has the same name, and say system.out.println, and we'll say we do what we're doing in our notes here. This. Let's replace this. Just the drivetrain. This is num seats. All right, so we create a print automobile function here. Now you can't see it, but it's really faint, but it's giving us a warning to add the override notation. So if I compile this, actually give me any issues. Let's stop it first. No, it didn't. So well, what if we did? I mean, this is kind of silly, but so this is also kind of weird with Java. Java seems to not care that we have two of the same functions. So when this gets called, before it was calling the automobile version, but now that it's calling Kristen's traverse version, which is the traverse version of this call, I bet it's going to call down here. So I'll put some breakpoints in these two files just so we can see which one actually calls. There are some slight nuances. So it looks like it's calling the traverse version. So what if we came across something like this? So typically, you can do this in other languages as well. Is have the same function name. Typically, we do get a warning signing say, "Hey, add the override notation." That's more of an indicator to that should be there as an indicator to any developer that opens this up and says, "Oh, print automobile." If they see that override, you basically have to understand that that's same function or name is used elsewhere. But what if what if we wanted to actually utilize this function that was in our parent class? Well, you can do that, and there's basically a keyword called super. So super basically means anytime you use the word super, it's basically referring to the parent class. So in this case, our parent class is automobile. So if I say super dot, you notice here you see all the functions in the parent class. So if I call super print automobile, it's actually going to jump over here and call this first, print these out, finish this function, and then we'll finish with our next two lines here. So just so you can see that's what happens. If I hit this, we go ahead and break over here, F8, F8, F8. We're back over here, F8, F8, and if we're going to look at our output, sure enough, all those things printed out accordingly. So the super keyword basically lets us access stuff from the parent if, especially if you come across a case like this where you have a function that has the same name as another function in the parent class. So that's kind of nifty. And a lot of times if we put a so here one thing I guess we can check here is that let's go over notes. Yeah, well, one thing you can notice here, it's maybe not necessarily a great example here, but when we're going through our example, we're creating a new traverse. You can notice here that I didn't specify a constructor in the traverse class, but at the same time, it looks like it's the default class in our automobile is definitely getting set. So we're not setting that Chevrolet value anywhere, but when we print it out, it's certainly there. So that just means in Java, the parent class is automatically called, in when you create it. And at least the default class. This is called a default class. Remember, constructors are called default when they don't have any inputs in there. But what if we actually created another constructor that took a took a color as an input? So instead of having it be red, the color would basically default to whatever value is passed in there. Well, what if we wanted to call this specific function? Well, again, that's where the super keyword comes in. So here, let's create just a default. So this is a constructor. I'm not going to do anything in there right now, but say we wanted to call this specific version. And we could do that by saying super and then put the string name in there. So this is calling the parent class constructor that takes one input, which would map to this guy. And just so you know, I'm not lying here. Put some breakpoints. Let's run this. So we're on this line. If I hit F8, it should jump over here. It does. Sets the color from the black value we put in there, kept the make as Chevrolet, and came back out here. So I just want to point this out. This is how you can access constructors and from a child class. If that constructor had what was not a default constructor, as you saw previously, the default constructor is called automatically. Okay, so this function is going to be called if we didn't have this and we're specifically calling this, then the default constructor would be called. But because we define a constructor in the child class, it's actually going to look at that first and set this to, or we can then call another version of the constructor if need be. I guess that's it. Is there anything else I want to go over here? I don't think so. So that was basically a introduction to inheritance. Again, we create a parent class. We have a child class. Extends keyword is what signifies that to the compiler. Access modifiers. Protected means it should just mean stuff within the class itself, and child classes can access it directly like this. But in Java, it also means anything in the same package. See color. In C#, that anything in the same package, the thing is usually you use the term internal, or the same assembly is used as internal. But just some slight differences between different programming languages. And then finally, we talked about what if you had a instance where you had a function name that was the same kind of function name as something that existed in your parent class. Well, you can use the wonderful super keyword to call that function as well. And the override word there is simply just to tell a developer that, hey, check for another definition of this function in the parent class. All right, well, that's it for this video.